Hey, everybody. Welcome to our new schedule. All right, new schedule. We're Zooming for an hour and a half now. Okay, but part of that time is we're going to be doing these warm ups in class now, and we're going to be going over homework answers in class and starting homework in class. Okay, so we have time to do that now that we get you for this amount. Let's make a big push these last 2 months. Okay, let's push hard and prepare ourselves for 7th grade math and science. Okay. All right. You know the drill. I'm going to press pause. Everybody's going to go copy this down, and then you'll start doing what you can do, and then you'll come back and or ask your teacher for help if you need help on certain problems. Get hints, and then we'll go over them all. Okay. Remember, when you're doing these problems, evaluate for the values given. All you're supposed to do here. What's that one word for the directions for that? Remember, I always say pretend like you're a soccer coach. When you see evaluate for the value given, you get to substitute. Okay, what does that mean? If you're trying to figure out what is 3x plus 1, and they're saying x equals 5, then you're going to go put in 5 for x. If x equals 5, you can replace the x with a 5. Now, make sure you don't just write 35 plus 1 now, though, right? What does 3x mean? That means 3 times x. So either put that 5 in parentheses so you know to multiply it, or put a dot there, okay? And then you're going to do it with the 2/3, right? When you're done with that, you're going to 3 times 2/3 plus 1, okay? All right, so that's what you're doing this. When it says to make these ratios rates, remember what you're going to do on that? A rate is just like a ratio, but the bottom number or second number is 1. Okay. So for 135 miles for 3 hours, that's a ratio. If I want to find out how many miles per hour, that's 1 hour, then I have a rate. Okay. And to do that, you're always going to divide the bottom number to the top, divide the denominator into the numerator, the second number into the first number. Okay. So I'm going to go 3 into 135, 6 into $7.20, 3 into 4.5 cups. Okay. All right. And don't forget the order of operations. Okay. On these problems, you're getting the parentheses first. They can be the normal parentheses. They can be the fancy ones. They can be the big blocks, but you're going to do any of those things first. Then you're doing the exponents. And what's the opposite of to the second power? Square roots, if you have any of those. When you're done with all those, then you get down here and you'll do the dividing and multiplying. And it doesn't matter if they write it with a backslash or dot. And if you have more than one of those, you'll go, the ones on the left happens first, okay? And the last thing you do, the simpletons, that's when you subtract or add. And again, same thing there. You're going from left to right if you have more than one of those type of problems, okay? All right, we'll see you in a bit. And let's zoom out of here a little bit so we can get the whole paper on the screen. And how about these diamonds? Okay, what two numbers have a product of 36 and a sum of 15? You multiply, you get 36, and you add, you get 15. Because I know that like 4 times 9 is 36, right? 4 plus 9 is 13. And I know that 10 plus 5 is 15, but 10 times 5 is 50. So it's got to work for both, okay? This happens to be 3 dozen. 3 times 12 is 36. 3 plus 12 is 15. How about the 36 and 20? 6 times 6 is 36, but 6 plus 6 is not 20, huh? How about 18 and 2? 18 times 2 is 36. And 18 plus 2 is 20. 1,000th and 1100ths, huh? Is that going to work? This is going to end up being 1/10 and 100th. Remember, when you go to add decimals, you stack them. So I'm putting that 10th here. When I go write that 100th, I put the decimal down first. Then I put the 0 and the 0, 1. Okay. Now, see how this comes out one more place? I usually fill in the 0 there, so it's not as confusing. The decimal comes straight down. When you add, you do get 1100ths. When I multiply, you pretend like there's no decimal. Go 1 times 1 is 1. But I had to move this over one spot to pretend it was a 1, and I had to move this decimal over 2 spots to pretend that was a 1. So that's a total of 3 spots. I moved decimals in my problem. I got to go back 3 spots in my answer. Okay. And what was yesterday? Yeah, Easter. Fill in those eggs, right? 1,000. See how that worked? All right. How about this one? Did I stump you on this one? 3 times 1 1/3. That's 3 wholes and 3/3. 3 3/3 is the same as 4. When I add 3 plus 1 1/3, I get 4 1/3. Okay, so that was one of those ones that looked harder than it was. Okay, but until you get good at these, that's still going to be a tough problem. Don't feel bad if you didn't get it. All right, so I'm going to substitute. 3 times 5 is 15, and 15 plus 1 is 16. I put a circle around my answer, put a box around that problem. Start doing that. It's a good habit. Okay. Now, multiplying fractions is easy, but that 3 is not a fraction. It's a whole number. Do you know how to make it a fraction? Watch carefully when I go through all these steps, right? Boom, boom. All you got to do, put a 1 under it. 3 is the same as 3 over 1. So I got 3 times 2 on top. That's 6. 1 times 3 on the bottom, and 6/3 is the same as 2. Now, that's the 2. I got to add the 1. 2 plus 1, 3. Put a circle around your answer, box around all your work so you know where it was. Okay? All right, 12a minus 1 if a equals 2.5. So I got to go 12 times 2.5. Pretend like there's no decimal. Put a placeholder. Here I got 300. However, that was 2.5, so I have to move the decimal over one spot, 30. And it's 30 minus 1, 29. Okay, now all that work included, right? Now I'm going 12 over 1 because I want to make it a fraction. And here I'm going to go ahead and use a C method and make this a fraction, right? 3 times 1 is 3, plus 1 is 4. So 1 1/3 is the same as 4/3, right? That makes sense because 1 whole is 3/3, plus 1 more is 4/3. Now I'm going to go 12 times 4 on top and 1 times 3 on the bottom. And then I'm going to show you how you could have made that a little bit easier. So 4 times 12 is 48. 1 times 3 is 3. And then I have, okay, so I'm back at it. Sorry, I was right in the middle of this. We were talking about that 48/3, and now I can simplify because 3 goes into the top and the bottom. Now, I know 3 goes into 48 16 times, but if you don't know that, you got to come up here and divide, right? I know that 3 goes into 48 because 4 plus 8 is 12, and 3 goes into 12. And that's a cool trick you can play with 3's. Okay, so 3 goes into 4 one time. I go 1 times 3. I subtract, bring down that 1. Okay, now that after I subtract, I'm bringing down the next number. How many times is 3 going to 18? Perfect, 6 times, right? So that's how I got my 16. Now, what I wanted to show you is you can do what's called cross cancel. See that 12 over 1 times 4 over 3? I can say 3 goes into the bottom and 3 goes into the top, even though it's not right above each other. It could be right above each other because 12 times 4 is the same as 4 times 12, right? So I can flip those two and say this is the same as 4 over 1 times 12 over 3. Well, if you said 12 over 3, you'd simplify. But you don't have to go through that extra step. You can trust me, trust your teacher, that if something goes into the top and the bottom in a multiplying fractions problem, you can do what's called cross cancel. You can say 3 goes into 3 once here, 3 goes into 12 4 times there. And now my problem becomes 4 times 4 on top, 1 times 1 on the bottom. 16 over 1 is 16. So I end up with smaller numbers to multiply, and then I don't have to simplify when I'm done and figure out how many times 3 goes into 48. Okay, so it's a good little trick to learn and practice. Okay, practice what they call cross canceling. Make your problems a little easier. Okay, so here we go. We have these rates. We're going to make ratios. Okay, so we have 3 into 135. And again, the standard algorithm when you go divide is you say 3 won't fit into 1, it'll fit into 13. Make sure you put your first number above that 3, because remember, it wouldn't fit into 1. Some people will actually put a big X through that above that 1 to make sure they don't put a number there or put a 0, right? I'm saying 3 goes into 13 about 4 times, because 4 times 3 is 12. And I subtract. What do I do after I subtract? Bring down that next number. And 3 goes into 15. Perfect fit, right? 45, right? 5 times, so 5 times 3 is 15. So 135 miles per 3 hours is the same as 45 miles per 1 hour. Okay. Okay. Or you saw it on the freeway sign, MPH. That's what that stands for, MPH, miles per hour. And again, that is what they call a rate, which is a special kind of ratio, with the second number or bottom number being a 1. Okay. All right. So this is 6 pounds, LBS. I'm going to figure out how many dollars per pound for these apples, right? So what am I doing? I'm dividing the bottom into the top. And don't freak out when you see a decimal. What do I say? Inside the box. Okay. All you have to do is bring it up and divide. Okay. So 6 goes into 7 one time. 1 times 6 is 6. Subtract. What do I do now? Bring down the next number. 6 goes into 12 2 times. 2 times 6. Perfect fit. Okay. So 1.2. Now this was dollars, right? So I'm going to go ahead and put that 0, because it's going to say $1.20, and I'm going to say per pound. Okay, per pound. LB is the abbreviation for pound. Why? Ask your teacher. It's all about Latin. Libra. Okay, 4.5 cups of sugar for 3 batches of cookies. I want to know, what is the rate of cups of sugar per batch? I'm going to divide the bottom into the top. 4 1/2 divided by 3. Now remember how we do this. Make this the improper fraction. 2 times 4 is 8, plus 1, 9. 9 halves divided by, make that a fraction, 3 over 1. And then Miss Nord said, smell my feet. The S, same. Leave that first number the same. 9 over 2 stays the same. M, I'm going to multiply instead of divide, because multiplying fractions is, hopefully everybody shouted out, easy, right? And that F for feet really means to flip. I'm going to flip that second number. Instead of 3 over 1, I'm going 1 over 3. Right, then I can go straight across the top, 9, straight across the bottom, 6, and 3 goes into the top and bottom, huh? 3 goes into 9 3 times, goes into 6 2 times. 3 halves is the same as 1 whole and 1/2. So this is 1 1/2 cups per batch. Okay, see, and then you can do that backslash. It's kind of like putting it on the bottom of the fraction. Okay. All right. What do we have here? We have order of operations problem. I'm going to do this parentheses first. Inside that parentheses, I have exponents and subtracting. What I'm going to do? Exponents. Now, 5 to the second power is not 10. 5 times itself that many times. So this is 25 minus 23. Okay. Don't be afraid of doing what I just did and rewrite what's left. 25 minus 23 is 2. Again, get used to just writing it over. What do I have now? 8 times 2, 16. And what's the difference between 18 and 16? 2. Try to solve it like I just did, step by step, going down, rewriting what's left each time so you don't forget anything. Okay? All right. Big set of parentheses. Inside, I have a smaller set. I'm going to do that first. What is the product of 3 and 17? 51. Okay, that's on the inside parentheses. I have 2 times that, right? And 98 plus 2 is 100. But don't do that. I actually put that in there because I knew that 2 goes with that 98 and you would be tempted, right? You got to multiply before I add. Remember that adding happens last, adding and subtracting. So what is 2 times 51? 102. So this big set of parentheses, these brackets, is 98 plus 102. What's that backslash mean? Divide. Okay, now 98 and 102 make a nice even 200. And I'm going to divide that by 5. But I got to do this exponent. So I'm not really divided by 5. I'm divided by 5 to the exponents, right? Exponents happen before I divide. 5 to the second power, 25. And what's the quotient of 200 divided by 25? Well, think of quarters. 25, 50, 75, 1, 25, 50, 75, 2. This is the big snowman. Goes 8 times. Okay. Now, again, lots of different steps, a lot of places to make a mistake and go wrong, either by making a mathematical error or going out of order. Okay. So don't feel bad if you got it wrong. Feel bad if you got it wrong and you didn't show enough work to find out where you went wrong. Okay. All right. Have a great day, everybody.